I welcome you to this session of geometry. In this session, we will take a look at some basic properties of circles. So first, let us look at some basic terminology. The figure shaded red labeled as OAB is known as sector of a circle. Sector is always represented by the angle made at the center, theta. So when we say we are measuring a sector, we are basically measuring the angle made by the sector at the center. So angle theta. Area of a sector, as we've already seen, is calculated as theta upon 360 into pi r square. The line PQ is called as a tangent. AB is a chord. A chord divides a circle into two segments. So the two shaded areas of the circles are known as segments. This larger segment is called as the major segment, and this minor segment is known as the minor segment. So let us now move to the properties of circles. First, we have equal chords are equidistant from the center. So we see here three chords, and these chords are AB, CD, and EF. And the perpendicular distance measured from point O on each of these chords will be the same. So these distances ON, OM, and OP are all equal. So we can write ON is equal to OM is equal to OP. Another property that we have is perpendicular drawn from the center on any chord bisects the chord. So if we have OM as perpendicular to AB, then the point M will bisect the chord AB and we'll get two equal halves. AM is equal to MB. Similarly, if OP is perpendicular to chord EF, OP will divide the chord into two equal halves, EP, which is equal to PF. Next, we have the property angle subtended by an arc at the center is twice the angle subtended by the same arc in the other segment. Now, for those of you who do not understand the term arc, let me show you here. So here we have a point A on the circle and there is the point B. The distance between AB around the circle, around the circumference of the circle, is known as an arc, and we read it as arc AB is nothing but arc AB. Now this arc, the smaller one, is a minor arc and the larger arc will be known as a major arc. Subtending an angle means the minor arc AB subtends an angle theta at the center, this way. This angle theta is the angle subtended by the minor arc AB at the center. The property says that this angle theta is 2 times the angle subtended by the same arc in the other segment. Now, as we had seen that the line AB, the straight line AB, divides the circle into two segments. Minor arc has made an angle that is equal to theta by 2 in the other segment. Now suppose it were the other arc. Let me draw that for you. Say we consider this angle theta. This angle theta has been made by the major arc AB, this one. And because it is the major arc AB, it will subtend an angle theta by 2 in the minor segment. So this angle here is theta by 2. A direct outcome of this property is the property that angle in a semicircle must be 90 degrees. Now, what do we mean by angle in a semicircle? Suppose we draw a diameter, say XY is a diameter. Now this diameter, what is the angle made by this diameter at the center? It is 180 degrees. So diameter must make 180 degrees at the center. Therefore, this diameter will subtend an angle at the circumference in the other segment, which is half of this 180 degrees and which must be equal to 90 degrees. So this angle T here must be 90 degrees. The previous two properties also lead us to another very significant property, that the same chord will subtend, or the same arc will subtend the same angles in the circumference. For example, we have this arc AB and we have these two angles subtended by the arc AB, angle ACB and angle ADB. Since both these angles are subtended by the minor arc AB in the circumference, the values of both these angles must be equal. And therefore we can say angle ACB must be equal to angle ADB. And if we draw any other angle on the same segment or the same circumference, it will be equal to both these angles. Say we draw AEB. So angle AEB also will be equal to angle ACB or angle ADB. Another thing here, if we have two equal chords, say chord AB and chord CD, suppose these two chords are equal. So therefore the value of the arc AB and arc CD must also be equal. And if they subtend an angle in the circumference, chord AB subtends angle theta on the circumference, and similarly chord CD subtends another angle alpha here. Therefore, if arc AB and arc CD are equal, then theta must be equal to alpha. Next we move to properties of tangents of the circles. The first property is, from an external point, let's say a point P, we can draw only two tangents to this circle. So we can draw PQ here and we can draw PR here. So from the point P we can only draw two given tangents and the length of these two tangents must be equal. So we can say PQ is equal to PR. Another property regarding tangents. We have a center O and we have a tangent PQ. The line joining the center O and the point of tangency Q must be perpendicular to the tangent PQ. This is another very important property of tangents. Another important point to mention here is, because the tangents drawn from an external points are equal, if there is a quadrilateral that circumscribes a circle, say quadrilateral ABCD, in this case we can see that the quadrilateral clearly circumscribes the circle. The sum of opposite sides must be equal. So AB plus CD must be equal to AD plus BC. So we can put it down as AB plus CD is equal to AD plus BC. So now let us summarize all the properties that we have covered so far in this particular session. So here is a quick summary. Equal chords are equidistant from the center and vice versa. Perpendicular from center bisects the chord and vice versa. Angle subtended by an arc at the center is twice the angle made by the same arc at the circumference. Angle in a semicircle is 90 degrees. From an external point, only two tangents can be drawn to a circle. The length of tangents drawn from an external point to a circle must be equal. The line joining the center and the point of tangency must be perpendicular to the tangent. And the sum of two pairs of opposite sides of a quadrilateral that circumscribes a circle must be equal. So you can just stop this video here and note down these properties or read through these properties if you wish to revise them or if you wish to study them quickly. So with this we come to an end of this particular session of circles. If you wish to watch more videos or if you wish to know more about the topic, please log on to our website pfindia.com. If you want to ask a doubt, please write to us at studentservices@pfindia.com. And if you're watching this video on our website, please use the Ask a Doubt feature. Thank you very much.